مش عارف انا شوي غيرت السيت اب اليوم، مش عارف كويس ولا لا. الاضاءه كويسه ولا فاقعه زياده؟ احكوا لي. تمام. طيب ثواني بس تحملوني، بدي ابدا تسجيل. اوكي انا راح احاول اعمل فيديو للبورد لحاله، مش عارف اذا هذا الشيء راح يفيد، خلينا نشوف. يلا بسم الله. Today is Saturday. الديت اليوم 21st. اوكي احنا we did yesterday work. اليوم we will continue energy and power. مش عارف وين الكتاب تبعي. طيب here is my book. hard to figure it out. طيب بنكمل وين البيجز في الكتاب اخر شيء، بس لانه هلا هون مش كثير مبين عندي، صعب اطوله كثير في كتب فوقيه. اكل yesterday we started work. سريع بس هيك ريفيجن. قلنا الورك what is it؟ قلنا هو it's a measure for the ability of a force to move an object certain distance in the same direction as the force. هذا قلنا this is the work done. This is the work done. قلنا الwork as an equation force times distance. بس remember with me distance is in the same direction as the force. وقلنا لأنه since the force and the distance may not be in the same direction, so we multiply by cosine theta just in case. But when theta equals 0 زي كل أسئلة الأو ليفل cosine is 0 equal to 1 عشان هيك تطلع work equal force times distance. But when theta equal 180 degrees اللي هي بتكون opposite to motion بيكون cosine ال 180 degrees equal negative 1 فبيطلع الwork negative. Negative means we are losing not gaining. We are energy is transferred. كلمة lose ما بحبها. Energy is transferred out from the system. While when it is positive, it will be energy is gained by the system or transferred to the system. But then, if you want to find the work when there is a varying force, we said we take the average force times the distance, assuming that the average force and the distance are in the same direction. And if there is a graph, it's better to take work and force and distance. It's better to take the area and the graph. Do we have such a case where we have varying force? حد بتذكر ب O level when we studied force here, distance was here, and it was straight line through the origin. تذكروا هذا what was the case? هذا case where was this? حدا بتذكر O level? Do you remember Hooke's law؟ صح؟ Hooke's law force and distance قلنا سميناها extension صح؟ ما هي distance، ما هي you have a spring it's moving right؟ فبيكون the force is not constant. In this case, if I'm asking you calculate the work done by the spring ما بتقول force times distance، يعني ما بتقول let's say this is 10 and this is 5، ما بتقول 10 times 5 because the force was not 10 all the time. Again, we take the average force. How do we take the average force? Let's say this is 0. So the average force is 0 plus 10 over 2 times the distance 5, and you can figure out the answer is 25 joule. Or if you take the area under graph, it's a triangle, it's half, the base is 5, this is 10, it's also 25 joule. So in both cases it's the same, okay? But just keep this in mind because it's important to understand how do we find the how do we find the how do we find the لحظة بس ثواني خليني عم بحاول أضبط الأمور. أيوه. Okay. How do we find the work done by any force? Just like if it was varying, you either take the average or the area under graph if there is a graph. Okay. Now, remember, work is a transfer of energy. What does this mean? I will explain it today. I'll explain what we mean by the work is a transfer of energy. Now, the energy that we will study, it's the kinetic and the gravitational potential energy, and later on, we will study other types of energy. Let's write now the kinetic energy. I know that everybody knows it. The kinetic energy, they write it EK. It's equal to half times m times v squared. This equation is given. I know that you will memorize it. It will be given. Now this is the mass. It should be in kilogram. This is, listen to me, this is the speed, not the velocity. Why? Because kinetic energy is a scalar. All types of energy are scalar. I'll write this note, don't worry. But this is the speed. The unit is meters per second, so that the kinetic energy is in joule. And remember with me, the kinetic energy and all types of energy are measured in joules. Let me write as a note here. All types of energy, one, are scalars. All of them are scalars. Two, they are measured in joules. Joule, we write it this way, or enough to write the symbol J, capital J. Okay, here in physics, in the A-level stuff, we may ask you to calculate the kinetic energy, or we may ask you to find the change in kinetic energy. The change, yani how much kinetic energy has been changed. So the change in kinetic energy, it's equal to kinetic energy 2 minus kinetic energy 1. So we write it half mv squared minus half m u squared, or we may write it half m v squared minus u squared. It's the same. It's the same. This is the change in kinetic energy. Either they write it this way or they write it delta EK. It's the same. Okay. So this is what? This is the change in kinetic energy. How much kinetic energy has been increased or decreased? We use this equation. Remember with me, some people, they do it this way. Go half m delta EK, go half m v minus u squared. This is wrong. This is not the same as this. They are not the same. They are different. Okay? So not v minus u, then you square it. No, you have the final velocity, you square it, then the initial velocity, and you square it, then you take the difference between the square of the final velocity and the square of the initial velocity. If it was negative, this means you lost kinetic energy, or energy is transferred, the kinetic energy transferred to other types. If it was positive, this means you are gaining kinetic energy. Nothing. Remember, this is wrong, okay? Don't use this. Don't make calculation easier by doing this. This is not easier. This is wrong calculation. Okay. Then, next. Now the gravitational potential energy. In all of it, we said GPE equal. Here, it was wrong to say GPE equal. Why? Because we don't know what is the gravitational potential energy at a point. Because the reference will differ between you and my reference. Maybe you are saying, what is the gravitational potential energy of sand? Well, Ustaz, you are standing on the floor, it's zero. You're like, no, it's not zero because I am here on the third floor, so I am above the floor by very high height, so I have gravitational potential energy. So here in this level, they will never ask you what is your gravitational potential energy. They will always ask you what is the change in your gravitational potential energy. They write it E-grav, like this, change. It's equal to M times G times delta H. Now this is what? This refers to what? This refers to the change in gravitational potential energy. This is the mass. Everybody knows that this is the mass. This is the gravitational field strength of Earth if we are doing a calculation of Earth. And this is the change in the height. This is how much your height has been changed. So H2 minus H1, change in height. Units, as you always, this is in joule, this should be in kilogram. This is, we said, 9.81 Newton per kilogram. And this is always in meters. Now, would delta H be positive or negative? Sure. If you are going up, like this, then the height, let's say, the height here was 0, it becomes certain number, anything. If the change, delta change is greater than 0 if you are going upward. So the change in the gravitational potential energy will be positive, bigger than 0. But if you are going downward, then the change in the gravitational potential energy will be less than 0, going downward. So this means the change in the gravitational potential energy will be smaller than 0, will be negative. Okay? So it's okay for delta H to be positive or negative, depends on the direction of motion, whether going up or going down. Sometimes they use the word in a level road. Level road means a straight road, horizontal. So there is no change in H. If there is no change in H, then there is no change in the gravitational potential energy. So if I am riding a road, if I'm riding my car on a level road, when you hear this statement, level road means it's straight and not going up, not going down, so no change in gravitational potential energy. If it was clear that you are going up a hill or down a hill, then there is a change in gravitational potential energy, whether it's increasing or decreasing. Okay, next. Now we want to talk about the power, and then I want to mention after this we will mention the relation between energy, work, and power. Within this chapter, not this chapter, within this unit, mechanics and materials. In the materials, we will study a third type of energy. But so far, only 2 are required from us. Okay. By the way, this is the last lesson in mechanics. So next lesson will be in materials. But we need to solve some questions. So tomorrow we will meet. مش عارف if tomorrow. I think not tomorrow. Tomorrow. Tomorrow we will meet. to solve some questions about energy, work, and power, because they are very challenging questions. They're very challenging questions there. And Balki, on Monday, if we get enough time, uh, uh, we will solve. شو اسمه هذا? We will start materials. Materials is not as long as mechanics, but we need some time there. يعني إن شاء الله we're on time. هلا ما بعرف if they will postpone the exams ولا لا. Just in case, and I'm telling you, just in case, if they give you the opportunity to do the exam or to withdraw your registration, if it was safe, yani there is no risk on you to do the exam, I prefer to do it. Don't delay it. We'll talk about this later on. Don't worry, بس هلا لأنه there are some rumors إنهم they are trying to delay أو مش عارف صراحة مو عارف بس okay. Power, and I defined it for you on O levels. We said power is the rate of doing work. So it's the rate of doing work, or it is the rate of energy transfer. So sometimes they will ask to calculate the power directly, sometimes they will not ask to calculate the power, they will say calculate the rate at which the work has been done, blah, 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 against the مش عارف شو, it's the same power. So this is the definition of power. In math, we write it power equal work over time, or any kind of energy over time. طبعا the energy here could be kinetic or gravitational potential energy. It should be the difference in the kinetic energy. Why? Because there must be an increase or decrease. Okay. Let me keep it the same. I will go back to this later on. Don't worry. We'll talk about it later on. This is joules. This is seconds. So it should be in watt. Okay. Let's go back to the general requirements at the beginning of this chapter, of the first semester. When we talked about general requirements, we said they may ask you to write any unit in SI base unit. These are SI units. The watt is an SI unit. The joule is an SI unit, but it's not base. The calorie, which is an energy for the unit for energy, is not SI unit. It's not. But the joule is an SI unit, but it's not base. احنا خلينا هيك بس just a quick revision. ساعدوني يا جماعة. يلا احكوا لي مين هم البيس. Do you remember what was the SI base units? Is an SI units. في عندنا بيس. أيوة. لحظة شوي. بيس. بالضبط. Kilogram, meter, second, ampere, Kelvin, and mole. These are the base. Now here the joule and the watt are derived. Now I will ask you, write J in SI base unit. Let's do it here. Write joule in SI base unit. You can take any equation, and you can start by half mv squared. Yes. You can start by force time distance for the work. Yes, ما في مشكلة. Let's do it with the work force time distance. So since work equal force time distance, then joule is a Newton times meter, but F equal M times A. So Newton equal kilogram times meters per second square. And I expect you to write these steps. And especially when he says show that, you need to show all of these steps. Not only the ones in red, okay? Everything. So J equal kilogram meters per second square times meters. So J is kilogram meter square second minus 2. They may ask you, this question is multiple choice. So you don't need to show your work. Sometimes they ask you to show that. Show that means you have to show all steps. Now write what in SI base unit. Here, this is the most common question. They get this يعني more than 5 times. الوات. فنقول power equal energy over time or work over time. So watt is joule over seconds. You have to show all of this. I will not show it again. Over second. So watt is kilogram meter second meter square second minus 3. And I advise you to remember it. They will ask you to do this 1 million times. At least if you remember the final answer, you may feel relaxed and you get the same final answer that you remember. Okay? Okay. Now okay. Notice that power equal work over time. And the work is force times distance times cosine theta over time. Now, if you see distance over time, it gives you speed. But what type of speed is this? Now, if I am asking you calculate the average power, you can use this equation, work over time, or you can take the average force times the average velocity cosine theta. Assuming if the force is constant, then it's the same. But if I am asking you calculate, let's say, the maximum power, assuming the force is constant, then you take the maximum speed cosine theta. At minimum, the same thing. So this is one of the equations that, in fact, it's not given. It's not given. I'm not sure if they wrote it in the new specification, but it was not given in all of the questions from 2009 to 2018. But in fact, if there is a tough question, we may depend on it to solve the equation there. So keep this in mind. And also, if there is work here and time here, and I'm asking you calculate the power, then we say power is the gradient. Power is the gradient. If it was curving, then you have to find the gradient of tangent. If it was straight, then it's the same. It's the gradient's constant, so there is no change. But if it was varying, I'm asking you calculate the power of the motor at 3 seconds. So you take 3 seconds, you draw tangent there. This is not a good tangent. Okay. And you may find the tangent, not like this. Not like this. You take 2 points. زي ما حكينا من زمان. We draw the tangent from the beginning to the end, and we take the gradient of tangent from the 2 extremities of the line that we've drawn, and draw the longest line that you can. Okay? Okay. Now, what is the relation between work, energy, and power. Work and energy, power is related this way. خلاص. Okay. Now this is the most important part. This is the tough part in language. If you are writing with me, don't write. If you are writing, just wait. We'll write together at the end. But now I will write something and I'll erase it. If you are just taking a photocopy later on, okay, ما في مشكلة. It is already recorded on YouTube, so you can go back and see all the notes there. Okay. Now if I'm asking you, let's say here there is a box at rest, and I start to push it by a force and move it to this distance. Now here the speed was 0, here it is moving, the speed is any number, I don't care about, let's say 1 meter per second, even it was 0.1, I don't care about the number. Now if I'm asking you, was there any change in the kinetic energy? The answer is yes. Now from where we get this kinetic energy? Please unmute yourself and answer this question. From where we get the change in the kinetic energy? حدا يجاوبني. صح. But I mean as energy transformation. يعني you say energy has been transferred from gravitation to kinetic, from what to what? Okay? Because there is an increase in the kinetic energy. If you calculate the kinetic energy, it was 0. Here calculated, inshallah, كانت 1 joule. I don't care about the number. There has been increase in the kinetic energy. From where this kinetic energy, this from what? Potential means if it was falling down, but it's not falling down. I just pushed it by myself. So what type of energy that causes the kinetic energy to increase? بالضبط. Force from the man, but the force is not energy. So we say the work done by the man causes a change in the kinetic energy. So my work is the reason it caused the kinetic energy to be increased. موافقيني؟ Okay? So here, if I ask you, calculate the work done, if you have force time distance, or if you have half m v square minus u square, you will find these two are the same answer. These two have the same answer. Why? Because my work, the work done by my force, causes the energy, the kinetic energy to be increased. Okay. if there is energy loss ممكن يكون minus, let's say, work done by friction. Could be. بس يعني yes, I agree with you. Yes. طب now, let's say if I will be killed by the end of these lessons because I keep writing on the wallpaper. Don't tell Susie. Now, if this is the box and I pushed it this way so that it moved till here. So now there is a change in the kinetic energy because it was at rest and now it's moving. So there is a certain speed. Also, there is a change in the height. So there is also a change or gain in the gravitational tension energy. From where all of this happens? From my force. So I can't say the force do this. I have to say the work done by my force causes a change in the kinetic energy plus the change in gravitational tension. This is what we call it work energy principle. So I'm going to write it in a good way. If you want to take subtitles, work energy principle. نقول the work done by any external force. What do you mean? Wait. The work done by any external force should equal how much there has been a change in the kinetic energy. If there was a change, maybe my work done did not change the kinetic energy, maybe it only changes the gravitational potential energy, or maybe it did not change the gravitational, it would change only the kinetic, or maybe it changed both. But what is this? This is what? This is the change, not kinetic energy, please انتبهوا, not kinetic energy. This is change in kinetic energy. This is change in gravitational potential energy. This is what? This is the work done by any external force. What do you mean by external force? External force means any force except the weight. What do you mean by this? Okay. In this example that I just have drawn here, when I said there is a box right here and I pushed it so it's moved up to here. What are the forces acting on the box when it was here? Maybe you tell me, says there was weight, okay. There was reaction. There was pulling force by the teacher. There was friction, okay. When you want to take this work done, you can take any of these forces, but not the weight. You are not allowed to put the weight there. Why is that? طبعا, if I'm asking you what is the work done by the weight, or the work done by the weight is the force times the distance. The force is mg, this is the weight, and the distance is the height. مظبوط؟ mgh. So this is it. This is why we don't put it there, because the mgh, the work done by the weight is mgh. It's already here. فما بصير تقول mgh equal mgh plus something. بتكون wrong mathematically. Okay. So here, what do we do, Ustaz? We take all work done by all forces, but not by the weight. So here, do you remember this demonstration? If I have this object and I want it to fall down, as it's falling down, what are the forces acting on it? Weight and air resistance. So you take the air resistance times the distance equal these two. But if I want to ignore air resistance, so you say zero equal. Okay, you say zero equal these two. مش عارف قديش الموضوع سهل. فاهمين علي؟ بليز يعني interact with me. قديش الموضوع سهل؟ قد ايه انتم فاهمين شو اللي انا بحكي؟ بعرف الموضوع it's not very clear yet. بس in this example هون لما انا عملت 1 2 3 forces, which of these 4 forces, sorry, which of these I will take in this equation? هلا بدي اعمل this force times the distance cosine theta. I want to take this force times the distance cosine theta. I want to take this force times the distance cosine theta and add all of these is equal to changing kinetic energy plus changing gravitational potential. But we don't take the weight, one of these forces. We don't put it here. We put it already. The weight is already here. It's given here. Sharik, we don't put it 2 times. Is this clear? It's merely an answer. Okay. شكرا يا أحمد. شكرا يا حبيبي. طيب. Now, let me go back to the first class that we took it in mechanics. If you remember at the beginning of mechanics, قلنا there are equations of motion, سميناهم equations of uniformly accelerated motion. قلنا we can take these, we can use these equations only when we are sure that the forces are constant, so acceleration is constant. Other than this, we can take it. So here we will see some questions where the forces are not constant and we can't use equations of motion. I will show you some of these questions. طيب. Okay, I want to take two questions. Question one, then question two, the one that I sent it to you on the WhatsApp. But let's do this question. Question one. No, a ball of mass m, unknown, falls from rest from 1.5 meters above the ground. Ignore air resistance. Calculate the speed by which it hits the ground. We did this question before, صح؟ مش عملنا؟ Did we do solve such a question زمان when we were talking about falling objects, صح؟ تذكروا هذا السؤال؟ We did it. And even in O level we did it. Okay. So here it is a constant acceleration equal to 9.81 meters per second squared downward. So we can use equations of motion, صح? So we can say I want the speed at the end, we can say v squared equal u squared plus 2as. V squared, this is the one that we want, u squared is 0, 2 times 9.81 times 1.5, this is v squared, so v equal, would you do the calculation for me? I have it here. Yeah. Square root of 3 times 9.81. لا غلط. ايوه صحيح. V equals 5.4 meters per second. Okay. This is simple. Or I want to show you how I can solve this question using the work energy principle. Or I may say work equal change in EK plus change in E grad. Now, the only force there is the weight, so 0 equal. There are no forces there. When there are no forces, no work is done. The only force there is the weight. We don't put it here. It's an internal force, not external force. Okay. Equal half m v square minus u square plus mg h2 minus h1. Now, what's the mass? We don't have it. بلاش. square. Initial is 0 plus mg. H2, the final, it lands on the ground, so 0 minus h, the original height. Now this is negative mgh, صح? This is 0 equal half mv squared minus mgh. So if you take it to this side, it's here half mv squared equal mgh. Now this is all level, I know. Mass cancels out. You can multiply these two by 2, multiply by 2. So v squared equal 2gh. So v is equal to square root of 2 times g times h. Look to it. Here is it. Here is it. 2 times 9.81. That's it. That's it. I don't want you to do this way. I don't want. If there is uniform acceleration, خلاص, don't depend on these. But if it was non-uniform acceleration, you're not allowed to use this. So you have to use this, and maybe you get the same final answer. معقول? Let me show you this question. طلع. Question 2. Let's say this is the pendulum. It's going like this. And the maximum height from the center to the center of mass, this maximum height is 0.30 meter. Find the speed here. Find the speed here. I know that the speed here is 0, so kinetic energy is 0. Here it is the kinetic energy is maximum. The height here, maybe to the ground, it's not 0, and here it's not 0, but the difference in the height is 0.3. This is what I want. So simply, I will use V equal square root of 2gh. So the answer is square root of 2 times 9.81 times 0.30. We have so many of these questions in the multiple choice, even without answer. They just want you to write it this way. خلاص, you know it. طب أستاذ, let me ask you, شافعي يا حبيبي, what are the forces acting on the ball while it's swinging? What are the forces acting on the ball while it's swinging? احكي لي. Wait. I want to ignore a resistance. It's pendulum. يعني it's hanging not freely. There is a rope holding it. So tension. Tension. طب أستاذ, أنت كيف استخدمت zero equal؟ يعني using this equation, I'm saying zero equal. Okay? How can you say أستاذ zero equal? Listen. Now here, work done equal change in kinetic energy plus change in gravitational potential energy. Not the weight. Don't put the weight. Again, put the tension. Tension times what is the distance? This is the distance moved. How much is this? I don't know. But what is cosine the angle? طلع. This is t. This is the distance moved. The angle is 90 degrees. And even when it was here, the weight is still down, the tension is here, the distance, it's always a 90. Cosine 90 is 0. But there are no work done, so 0 equal. This is why I can use this equation. So sometimes there are forces, but with no work being done. If there are no work being done, we can cancel it this way.
How did you know that the angle was 90 degrees?
ما هي التنشن دايما تانجنت للموشن، مش تانجنت، سوري، perpendicular to motion، لانه طلع عليها. ما هو انت هون بدك تاخذ الديستنس هي تانجنت لما بدك تاخذها از فيكتور تانجنت هيك هون هيك هون هيك everywhere the direction of motion is like this, the tension is like this, so it's always 90 degrees, the distance is always 90 degrees. And in fact this is true in all questions. The tension does not do work on hanging object, not the tension. Even the normal reaction force برضو كمان have no force there. Okay. طيب هلا let's say بيجي أسد wants to solve this question. نقول أستاذ بظبط نستخدم v squared equal u squared plus 2as. The final speed here is equal to the initial speed here 0 plus 2 times 9.81 times the distance moved, but because it's a vertical distance is 0.30. Tamam. You will get the same answer, صح? Same answer, right? Does this take 0 out of 4? This question takes 4 out of 4. This solution is accepted, this solution is not accepted. You can't use equations of motion. You can't, because this is a non-uniform acceleration. Okay? موافقيني يا جماعة? Do you understand what I'm saying? Okay. طيب. Now, let's jump to the question that I sent it to you via WhatsApp. If you have it, you can open it. If you don't, I will just draw and write all. Okay, so don't worry. If you have it, if you could print it out, بيكون أفضل. I will not stick to the requirements there. I will add some requirements. Do you have class after my class? في حدا عنده كلاس هلا بس نخلص؟ طيب. We may extend يعني our class شوي صغيرة أطول، معلش تحملوني لأنه أنا بدي أخلص هذا الدرس أو هذا السؤال بايخ شوي. هذا مبين إنه زي رولر كوستر. This is point is called P. This point is called Q. This height is 60 meters. This height is 10 meters. Here there is car with passengers that is going down from P to Q. Well, the diagram shows a part of roller coaster ride. The car begins its descent at P. It started at P, where it has negligible speed. So the speed here is 0. Almost. I mean, maybe not 0, but so this is assumption. It reaches maximum speed at Q. منطق. V here is max. This is normal. And then it starts descending, the decelerating. صح. If there were no forces opposing its motion, no drag, no air resistance, no friction, show that the speed of the car at Q would be approximately 30. Show that the speed here would be 30. Okay. Question. Can we use equations of motion or not? To answer this question, you need to check what are the forces there. When the car is here, what are the forces? Cool. Weight and load. Should be not to the surface. He wants to ignore the friction. Okay. Are these two forces constant? If yes, we can use equations of motion. If no, we can't. Are these two constant? No. No. R is changing even low value of R is constant. The direction is changing. يعني تخيل صارت الكار هون. When the car is here, the weight is still downward, but R is like this. So the direction changed. Even the value also changed, but even if the value is constant, when it's here, طبعا when it's at Q هون, weight is here, reaction is here. So the direction is changing. So we can't use equations of motion in this one. معناته أستاذ شو عمل؟ على طول go to work equal change in kinetic energy plus change in gravitational potential energy. نعم. عيد سؤالك حبيبي لأن قطع. ما كان واضح، ما سمعت. عيد بليز. مش ما عندها، عندها weight بس ما بنحطها within this equation. يعني نقول force times distance cosine theta equal half m v square minus u square plus mg h2 minus h1. هاي الفورس we're not allowed to put the weight one of the forces. هاي we're not allowed. حتى لو ما عندناش اياه، يعني he did not tell us what is the mass. مظبوط. بس even if we know what is the mass we don't put it here. فهذه cancelled، يعني ما بحط الويت، يعني ما بتصير تحط الويت. اوكي؟ طيب what are the forces here؟ احكوا لي. في عندنا R الديستنس يا احمد، الديستنس not given، بس ما هو كوساين 90. عشان هي اذا هاي زيرو ايكوال بالضبط. اذا هاي half mv square equal mgh. But here we have two heights, but you have to make sure you take the difference. فإذا 0 equal half m. The final, this is what we want. The initial is 0 plus m times 9.81. The final height is 10. The initial is 60. So 10 minus 60. So this is negative 50. This is negative 50 times 9.81 times m, here half mv squared. So you take it to this side, you see 50 times 9.81 times m equal half mv squared. M cancels out, is in v equal square root of 2g delta h, not h, delta h. نفس yes. If you are sure. هلا متى يا اسد ما بتستخدمها هاي؟ if here was not zero، يعني if the initial speed was not zero بدك تحطها هون، تحطها v square minus something، فما بتطلع exactly square root of 2gh. بدك تستخدمها عادي math simple math، بس ما بتكون زيرو. اوكي math is cancel out in both cases، ما في مشكله. احسبوا لي قديش بيطلع الجواب. I have 30. اوكي هو اصلا قالنا show that it's about 30، فاذا صح 31.3 meters per second. اوكي هلا part B. Now a braking system is used to prevent the car traveling faster than 27. يعني there is a braking system، احنا ما بدنا السبيد توصل 31، maximum 27 maximum. شكله اذا توصل عند 27 more than 27 it may lose contact هون وتطير ويصير شغله. ف for safety issues maybe. Braking system. The car and passengers shown in diagram have a total mass. هلا اعطانا الماس. اذا mass, total mass for the car with the passengers is 750 kilogram, and the length of the track from P to Q all of this distance is from P to Q is 80 meter. Calculate the average braking force, that would be required if the speed is not, if the speeds of the car to be limited to 27. So here V is 27. I am sure that V here is 27. Let me do my calculation here. خلينا He wants this force. The braking force. The braking force, this means there is drag force. It's opposite to motion. فإذا the drag that I want times the distance moved. It's all of this, 80 cosine 180. Why cosine 180? Because it's opposite to motion. Any drag is always opposite to motion. Equal half. The mass here is 750. The final, he said 27. Minus 0 square, minus 0 خلاص. Plus 750 times 9.81 times the final 10 minus 60. 10 minus 60. So this is negative 80F. If you take this, it's your plus 750 times 9.81 times 50, because it's already negative 50, equal half times 750 times 27 squared. طلع عليه. ليش اخذت لون؟ كان خليته هون. فيش داعي نحطهم، فيش داعي. خليني هنا. اوكي. Negative 80 F. Why negative cosine 180 negative 1? So negative 80 F equal half 750 27 square plus 750 times 9.81 times negative 50. Do the calculation, please. The final answer, it is 1,175 Newton. Please make sure that طبعا rounded 1,180. كان لازم نعمله to 3 significant figures, بس هيك كاتبين final answer, so I would depend on the final answer. نيجاتيف لا الجي هاي مش اكسلريشن ودي اكسلريشن. جي 9.81 دائما هذه غير equations of motion. equations of motion بدك تحط اب وداون تعمل اللي بدك اياه. هاي مش equations of motion. هاي change in kinetic energy, a change in gravitational potential energy. اوكي فلا تخربطوا الامور. طلعت مضبوطه هيك؟ Was it clear؟ شو رايكم؟ هذه بي ار، هذه بي ار. في حدا do you have any question؟ Okay. B double I, if you read with me, بيقول in practice the braking system would not have to produce this magnitude. Why? Why we don't need this magnitude? نعم؟ لا هو بيقول in practice يعني in real life يعني assuming the same situation. مش لا لا ايوه بالظبط، لانه there is air resistance مش بس braking force. احنا we assume انه braking هذا بس البريكس الموجود، بس في air resistance. اذا there is other خلينا نقول drag forces there. air resistance would act so it will help to reduce the speed, so you don't need 1175. maybe you need only خلينا نقول 900 نيوتن. ليه؟ لانه there is already 100 there is let's say 200 نيوتن من ال شو اسمها هاي ال air resistance, so you need only this difference. Then since in practice there is a friction، مش يعني الكار وهي ماشي لحالها مش في friction بدون البريكنج سيستم. البريكنج سيستم فيه زي system trying to hold the wheels، بس even if you don't hold the wheels there is in real life there is friction, normal friction and air resistance. Since in practice or in real life there are some drag forces acting in addition to the braking force, like air resistance and friction. These are two other forces acting in addition to the force of the what do you call it? Force of the braking. طيب هلا في عندنا احنا triple I. I want to solve it. بعدين I want to go back to I want to add another part of this question. هلا triple B, triple I, B, triple will explain whether the braking force would have to change if the car was carrying a heavier load of passengers. You may award the mark or I cancel it. You don't need to look at it. أقول if there are more masses, do we need the friction بتزيد. بس ما هو more mass means more kinetic energy، صح؟ أو حتى كمان more momentum. فأنت in this case you will need greater force to stop it. أنت خليك by logic يعني let's discuss this by logic. If I have يعني bicycle and I want to stop it, it's hard to stop it, but I may stop it. بس زي ما قلنا من قبل لما درسنا momentum, if the car now has a heavy student there، مش واحد مسلح و heavy student، بيكون صعب كثير to push him أو حتى to move him. فإذا بنقول الانسر إنه we need a greater force. We need a greater force. إذا هو يعني الريزيستنس لها دخل في السايز. عادة السايز او السيرفيس اريا between سائل وبتوين much heavier سائل مش هالفرق الخيالي. اوكي يعني فاهم شو قصدي؟ يعني انا ممكن يكون نفس الشكل بس اوعيه تبطل تدخل فيه لانه انا I gain weight، بس ما بكون الواحد كبر من هذا السايز، بكون كبر هيك. فهذا facing the car بيكون تقريبا same. يعني even if it has some effect it's not that important. فنقول إذا هنا more mass means more kinetic energy. So for أو هيك نقول so more work is needed to be done to stop the car, but work equal force times distance. Since the distance is the same and the work now is more, then this means greater force is needed. Okay? اوكي كلير هلا هيك واضح؟ طيب let's put اذا بدكم بارت 4 او بارت سي او ايش ما بدكم، هاي من عندي اكسترا مش موجوده في البيبر اللي انا بعثت لكم اياها. نقول calculate V اللي هي ال V max maximum speed velocity at Q if the drag force or the braking system, the total drag with the braking system and friction was varying, as in this case, if the drag force was varying as in graph. Let's say he gave us this graph. This is force, this is distance. Here it's the 80. Let's say straight line. This is negative 1,175. And this is the 80. So how do we do it? It was like this. Simply, we said work equal change in kinetic energy plus change in gravitational potential energy. Now the work here is the area under graph. We don't take force times distance because it's varying. This is half m v square, which we wanted. This is 0, and this is mg h2 minus h1. Now, as we said, this is 750 times 9.81 times negative 50. This is half times 750 v squared. This is half times base 80, height negative 1175. Now, if you do the calculation, it will be 750 times 9.81 times 50 minus half times 9.1 times 80 times 155 over half times 350. Okay, V, it will be 29. So here, the final velocity will be 29. So when there was no drag force at all, the final speed was 31. With the constant drag force equal 1,175, the speed reached 27. Here, because it's varying, it was not 27 all the time. The speed is between 27 and 31, it's 29. Logic, I accept the answer. Okay, tomorrow we will have more challenging questions. I will try to send some questions for you today. خلينا نقول I want you to try them مش homework بس يا جماعة please يعني it's hard for me to give you homework right now لأنه there are challenging questions there a lot في simple. So I want to do some classwork بس على أنه we don't have a smart board here and we can see the papers. I will send it before, try to print them, put them here in front of you. إذا لا try to get another screen عشان تضلك شايف شو أنا عم بعمل عم تطلع على السؤال you are reading. Try to do these questions on your own. الموضوع it's not easy, it's challenging. We need to do it on as much as we can. Tomorrow we will have I think يعني more time بجوز ناخذ ساعة ونص maximum ساعتين. بكرة بدي ألغي grade 12 عشان to spend more time with you عشان أقدر نخلص مادة أسرع. أوكي يا جماعة. ف tomorrow at 1:30 as today إن شاء الله بتكونوا جاهزين ونشتغل مع بعض. أوكي. يعطيكم العافية. حبيبي. باي باي.